I'm going to fill in the degrees of the quarters, okay? So this is 0, this is 90, this is 180, this is 270, and then it doubles back around to that 360. I know to fill in which line because they have that little degree symbol. Let's see if I can, there, okay. Then I fill in the angles in between. So the pattern for the angles is 30, 15, 15, 30. So from here to here is 30, then from here to here is 15, 15, and then 30. So after the 0 comes 30, then I add 15 and it's 45, then I add 15 and it's 60, then I add 30 and I get the 90 that's already there. I do it again. Add 30 to the 90 and I get 120. Add 15 and I get 135. Add 15 and I get 150. Add 30 and I get the 180. Do it again. Add 30, I get 210. Add 15, 225. 30, 15, 240. 30, and I get the 270, which that's really hard to read. And last time, 270 plus 30, 300, 15, 315, 15, 330, back to the 360. Good so far. Now we do the radians. So let's do the quadrant angles again. 0, pi over 2. I like to use the little space that's there as the fraction. You do it if you want to. Pi, 3 pi over 2, 2 pi. You good so far? Jacob, you filling it out? Yeah. All right, then every angle that's closest to the x-axis, so the one again closest to the horizontal x-axis, is over 6. So this is over 6, this is over 6, this is over 6, this is over 6. They all also get a pi. So pi, 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 pi. The ones closest to the y-axis are over 3. So over 3, over 3, over 3, over 3. And again, they all get pi. And the in-between is over 4. Over 4, over 4, over 4, 4. And they all get pi. With me so far. Now the first quadrant gets left as is. Pi over 6 is the equivalent of 30 degrees. Pi over 4 is 45 degrees. Pi over 3 is 60 degrees. Don't believe me? Convert it, okay? It will. I promise you it works. In the second quadrant, we do the numerator is one number less than the denominator. So this becomes 2 pi over 3, 3 pi over 4, and 5 pi over 6. They are one less than the denominator. Because if they were the denominator, it would be 1, which is pi, and this is less than that. In the third quadrant, it's 1 more than the denominator because we're now bigger than pi. So this is 7 pi over 6, 5 pi over 4, 4 pi over 3. More than the denominator. So quadrant 2, 1 less. Quadrant 3, 1 more. And then the last quadrant, they are just smaller than double, okay? So they're just smaller than 2 pi, which means they are 1 less than the double of the denominator. That becomes 11 pi over 6, 7 pi over 4, and 5 pi over 3. I also just memorized 5, 7, 11, because that's usually easier than 1 less than double, but that's what it is.
7, 11. 5, 7, 11.
Yeah, 5, 7, 11. 11. 11. 11. 11. 11. 11. 11. 11. 11. 11. 11. 11. 11. 11. 11. 11. 11. 11. 11. 11. 11. 11. 11. 11. 11. 11. 11. 11. 11. 11. 11. 11. 11. 11. 11. 11. 11. 11. 11. 11. 11. 11. 11. 11. 11. 11. 11. 11. 11. 11. 11. 11. 11. 11. 11. 11. 11. 11. 11. 11. 11. 11. 11. 11. 11. 11. 11. 11. 11. 11. 11. 11. 11. 11. 11. 11. 11. 11. 11. 11. 11. 11. 11. 11. 11. 11. 11. 11. 11. 11. 11. 11. 11. 11. 11. 11. 11. 11. 11. 11. 11. 11. 11. 11. 11. 11. 11. 11. 11. 11. 11. 11. 11. 11. 11. 11. with me so far? We're 2/3 the way done.
But do we have to memorize it?
So normally I'd actually give a quiz on this, but I mean,
This is the easy part. Then it's
like I said, I could stop you guys from having a sheet to copy off of, but they could literally, I mean, I don't know if they sell it, but they could wallpaper their room at Unit Circle at home, and as if it's behind here, I have no idea. So that's not fair. Yeah, so no, I won't. But the reason I teach it, you don't want to have to like use this to find every answer. You want to know this so well that you can reference it from your brain. What happens at 7 pi over 6? Okay, this is what happens at 7 pi over 6. Because the application of it is what will take you a long time if you have to look up your circle every time. Yeah. Okay, so now we're going to fill in all the coordinate points, and these will make a lot more sense when we get into like SOHCAHTOA and all that stuff, but I'm just going to teach you the coordinate points for now, and then we're going to get more into it on tomorrow. And this is important, and that this is more important than actually filling out the rest of it, is every over 6 has the same coordinate point. The plus and minus signs change, but every over 6 has the same coordinate point. Every over 3, let me go in order. Every over 4 has the same one, and every over 3 has the same one. Again, what changes is the positive and negative on it, okay? The over 6's are root 3 over 2 and 1/2. For me, I think it's like it helps me because 3 times 2 gives me 6. So I know that 3 comes first. Pi over 4, they're the same. If it's a 45, 45, 90 triangle, think about it, it has to be isosceles, so they'd be the same, which is root 2 over 2 and root 2 over 2.
the last one's back.
Good. And then the over 3 is the reverse of the over 6, which is 1/2 root 3 over 2. So every single one of those can get filled out, okay? So all my over 6's are root 3 over 2, 1/2, root 3 over 2, 1/2, root 3 over 2, 1/2, root 3 over 2, 1/2. All my over 4's are root 2 over 2. And all my over 3's are 1/2 root 3 over 2. Now think about the signs in these quadrants, right? In the first quadrant, what's positive, what's negative, as far as x and y values go? First quadrant, what has what signs? They're both positive, right? Because we're in that first quadrant, so we move right. Yeah, no, sorry. They're both positive. And again, when we get into 4-2, we're going to talk about this in terms of sine and cosine and tangent, but right now we're sticking to the xy's. In quadrant 2, now we're moving left and up. So the positive is the y, the negative is the x. So the x has a negative, and a negative. In quadrant 3, they're both negative. So it's a negative, a negative, a negative, a negative, a negative, and a negative. And in quadrant 4, good. The x is positive, the y is negative. Now let's go back and fill in those points, right? So this is a unit circle, which means we're moving right, up, left, and down 1. So what would be my coordinate point here? 1, 0. At the top, 0, 1. On the left, negative 1, 0. And on the bottom, 0, negative 1. So you do not need this graph. You don't need this for 4-1 homework, but you will for 4-2. Okay, and I wanted to teach it to you like live, sort of live, in person, okay, because we're going to learn how to apply that after this next step. So you're not going to get a unit circle on a standardized test, so keep that in mind. There has been trig-based questions in standardized tests previous to this Okay, so there is possibility of referencing this unit circle. And so it's so important to know it and not have to look it up every time to answer questions. So the more you can practice it, the more that you understand the pattern involved, especially these, like knowing the coordinate points that match with the certain kinds of angles.